Hey, Advanced Math. Gonna work on a new ratio proportion kind of topic today called scale drawings and scale factors. So go ahead and make that the title of the next page, free page in your math book. Today we're just talking about the basics of scale drawings and scale factors. And when you have got that all written out, unpause and give me your concentration. All right, so really basic ratio problem, since we've been working on these for a long time now this year. Something like this: if 52 girls and 48 boys are in fifth grade this year, if each homeroom has 1/4 of the students, how many boys and how many girls would you expect in the class? That's a pretty basic ratio problem. If we would say the ratio of, say, boys to girls is 48 to 52, and if 1/4 are in each class, that's a ratio, a proportion, right? We would expect 1/4 of these and 1/4 of these to be in each class, and we would expect that to be 12 boys and 13 girls. And so we have solved ratios like that many times, or proportions like that many times, and we're going to solve a new kind of problem in a very similar way today. So here they are. It's going to involve drawing. So if you like drawing, today's your day. So here's how it goes. This is a rectangle is 1/2 inch wide and 1 inch long. Draw a similar rectangle using a scale factor of 3. So let me take this bit by bit and talk to you about how that works. So let me start. A rectangle is 1/2 inch wide and 1 inch long. I'm going to draw that rectangle first. So 1/2 inch one way and 1 inch the other way. So pretty small rectangle. So it's 1/2 and 1/2 and 1 and 1. So there's my original rectangle in the problem. So in math, the word similar in geometry, when you're dealing with shapes, means that the shape is either larger or smaller by the same ratio on every side. So that's what I'm going to do here. I'm going to draw a rectangle. It's going to look like this one, but as a scale factor of 3. Scale factor of 3 means every side is 3 times larger or longer. Right? That's a ratio or a proportion. So I'm going to draw an exact same rectangle, but 3 times bigger. It's going to be a ratio of 1 to 3 in my new one. Each thing here is going to be 3 times that size over here. So it's really like solving a ratio here, where my ratio here, the width to length, the ratio of the width and the length right now is 1/2 to 1. And so my scale factor of 3 means my ratio for my new rectangle is just going to be in proportion, like I'm taking 3 sets of that rectangle. So my new one's going to be 1/2 times 3 is 1.5. 1 times 3 is 3. So that's going to be the width and the length of my new rectangle. It's a new rectangle that has the same ratio of sides and is just scaled up or scaled down to be bigger or smaller. So now I can draw that one. So my new one's going to have a 1.5 inch width and a 3 inch length. So that's 1.5, and that's 3. And if you look at those rectangles, they are in proportion to each other. It's not like this one's tall and thin and this one's long and short or anything like that. It's just a scaled up version. I took this times 3 times 3, and I ended up with my new rectangle. So those are called mathematically similar. I know that in language arts, the word similar kind of means something else. It means like not exactly the same. In math, it means in proportion when you're talking about shapes. So the ratio of the sides on the big one is the same as the ratio of the sides on the small one. Okay? So let's do a reverse version of that. Here's two triangles that are already drawn. It says the following two triangles are similar. That means, same ratio of sides. What is the scale factor? So what is that number I multiplied by to go from this one to this one? So the last one, I gave you the scale factor and we drew the rectangles. This one I'm giving you both the figures and we need to find the scale factor. So I've got 3 measurements here. This one is 5 by 3 by 4. I can really use any 2. If I know they're similar, it doesn't really matter which 2 sides I deal with, or I can do it with all 3 sides. But I've just got to match up same sides here. So in my larger one, I've got a 5-inch side going to a 3 1/3 inch side over there. And then I've got a 3-inch side going to a 2-inch side. And I've got a 4-inch side going to a 2 2/3 inch side. And since I know these are similar, I know I can multiply these by the same thing to get to this number, and I just need to figure out what that is. So I'm trying to figure out 5 times what equals 3 1/3. 3 times what equals 2. 4 times what equals 2 2/3. And I know they're all going to be the same because it's the same ratio. So I think the easiest thing for me to figure out would probably to be in this one, where I don't have any fractions. 3 times something is 2. So let's see. It's going to be a fraction because I know it because it's getting smaller, right? So let's see. 3 times 1/3 would be 1. So it seems to me like 3 times 2/3 would be 2. And so same thing up here. 5 times 2/3, that is 10/3, which is 3 1/3. And 4 times 2/3, that is 8/3, which is 2 2/3. So here my scale factor is 2/3. This triangle is 2/3 the size of this one. Okay? So that's called a scale factor, and those are similar. It means all their sides are in the same ratio. All right? Open your math notebook up, and let's do a couple of these together. All right, so let's start with where you draw. You may not have a ruler to do this, so you may want to, if you don't have a ruler, to make your parallelogram exactly 6 inches. Kind of your knuckle, that's probably about 1 inch, and if you just want to make it be 6 of those and 2.5 of those, it won't matter if you actually do inches as long as you use the same thing to measure everything. So you could do finger or knuckle, or if you have a ruler or a protractor or something, go grab that. So draw a similar parallelogram to the one drawn using a scale factor of 1/3. So when I look at this parallelogram, my ratio of sides, I'm going to call that, I guess, my length, and my diagonal. My ratio there is 6 to 2.5. And if I'm going to draw this by a scale factor of 1/3, that means I'm going to make sure I keep that ratio exactly the same. So I'm going to scale that by 1/3, and I'm going to get the same ratio just in a smaller size. So 6 times 1/3, that is 6/3, which is 2. 2.5 times a third, let's see, that would be 5 halves times 1/3 is 5 sixths. So I'm going to have a ratio in my smaller one of 2 inches to 5 sixths of an inch. So let's see, this is going to be kind of hard to do. Let's see if I can do that. I can do it probably. So now my new one is going to have a length of 2. It's going to be hard for me to make this same angle without a protractor here, so I'm just going to do my best. I may not exactly match the angle. In a great scale drawing, you would. And I'm going to go 2/3 of an inch. Let's see, I've got, this is divided into 16ths, that's 3/4, so 2/3 is right there, I believe. And then another 2 from here. Similar parallelogram. This one is 2 and 5 sixths. So you'll notice they look like they're the same shape. Everything's in proportion, it's just smaller. You know, I've gone from 6 to 2 and from 2.5 to 5 sixths. Everything's in the same ratio. They're just different sizes, but everything's proportional to the original one. Okay? So that's a scale factor, if you want to make sure you know that word, and the word similar is important too. It means larger or smaller by same ratio. Okay? Turn your page, let's do one more where we find that scale factor. I wrote this before I drew my picture, and I had to draw my picture into the words. Sorry about that. So these two triangles are similar or proportional to each other. What is the scale factor between them? So this one, I have a ratio of height to length of 2 to 3/4. This one, I have a ratio of height to length of 5 to 1 7/8. So I just need to know what was that scale factor I used in order to go from one to the other. Right? Obviously, since they're proportional, I multiplied both of those sides by the same factor, the same scale, and I just need to figure out what it is. The numerator is going to be easier for me to figure out in this case. I know how to get from 2 to 5. 2 times 2 is 4, and 2 times 2.5 is 5. So I believe this is a times 2 and 1/2 scale. I can double check that with a calculator on the denominator, and I'll do that for you, just to be safe. 3/4 is equal to 75 hundredths times 2.5 is, that is in fact 1 7/8. If you reduce that all the way, it is. So that sums 2.5. So my scale factor here is 2.5 from there. All right. That's the basics of scale drawings. There's some more neat stuff that goes along with scale drawings that we'll look into tomorrow. But that's the basics. So hopefully that was no problem for you. If it was, please go back and watch these examples again. If it wasn't,